Lidar. Light detection and ranging. Lidar is a remote sensing method that uses laser to measure elevation like ground, forest and buildings. Lidar uses ultraviolet, visible or near-infrared source to sense objects. Light energy emitted by Lidar system is known as pulse. Light reflected from ground or object is known as return. This means the Lidar system sends a pulse of light and it waits for the pulse to return. It measures how long it takes for the emitted pulse to return back to the sensor. In the end, it gets a variable distance of the objects. Actually, this is how Lidar got its name: light detection and ranging. Like sonar uses sound waves to map things, radar uses radio waves, a Lidar on the other hand uses light sent out from a laser. A Lidar unit scans the ground from side to side as the plane flies. Because of this, it covers a larger area. While some pulses will be directly at nadir or a straight line, most pulses travel at an angle. Airplanes, unmanned aerial vehicles, and helicopters are the most commonly used platforms for acquiring Lidar data over broad areas. There are different ways to collect data using Lidar: from ground, from plane, or from satellite. There are three types of Lidar. Topographic Lidar. It maps the land typically using near-infrared light. Bathymetric Lidar. It uses water-penetrating green light to measure sea floor and riverbed elevations. Terrestrial Lidar for mapping buildings, natural features and trees at ground level. It is also very useful for 3D models of heritage sites. How does a light detection and ranging system work? There are 4 parts of an airborne Lidar. Lidar sensors scan the ground from side to side with a pulsed laser beam as the plane flies. The sensor has a detector for sensing the returns from objects. GPS receivers track the altitude and location of the airplane. These variables are important in attaining accurate terrain elevation values. Inertial Measurement Units, or IMU, tracks the orientation and speed of the airplane as it flies. Elevation calculation use orientation to accurately determine the actual position of the pulse on the ground. Computers record all of the height information as the Lidar scans the surface. These 4 parts of Lidar system work together to produce highly accurate and usable results. Lidar is used for wide area mapping, coastal changes, floodplain mapping, and for engineering applications like for mapping bridges and roads. Lidar system allows us to examine both natural and man-made environments with accuracy, precision, and flexibility. In the next part of the Lidar story, we talk about the various uses of Lidar in detail. Keep watching.